is Shakil Ahmad, your biology educator. And today we are going to discuss the dilutions that we do in biology. In biology practical exams, we usually have the dilutions which are included in the part question number one of the paper. So we have the dilutions and we will do the introduction of the dilutions and then what is the serial and the proportional dilution. So dilution is nothing but adding more solvent to the solution and decreasing its concentration. We can never increase the concentration. We are always asked to reduce the concentrations, and the concentration is reduced by adding water to the solution. Now we have dilutions of two types. One is the serial dilution, in which we decrease the concentration of the solution by the certain factor and we do it continuously. So in case of the serial dilution, we usually have the questions coming of two types. Either we have to reduce the concentration by a factor, usually the factor is 1/10, or we have to reduce the concentration by half. So if we are asked to reduce the concentration by 1/10, what we do is we take the 1 centimeter cube from the solution, the stock solution that we are is given, and we add 9 centimeter cube of water to it. So the ratio is 1:9 between the stock solution and the water. This is done if we have to make the 10 centimeter of the total solution. So we will do it continuously. The solution that we have made from here, then we will do the same thing with it. We will take 1 centimeter cube of this new solution that we have made and add 9 centimeter cube of water. We will do it continuously with each dilution that we make. So here is a picture of how we do the serial dilution to reduce the concentration by the factor 1/10. You can see we have taken 1 ml from the stock solution and add 9 centimeter cube of water. Then from this solution, we take 1 centimeter cube of the solution, add 9 centimeter cube of water. And then from that solution, so we do it continuously to reduce the concentration by the factor 1/10 in each dilution. So I have, for example, I have taken here an example from the paper, which is Winter 20 variant 34. Here we have the 1 centimeter of the 1% starch solution and we don't add any water to it. Now what we do is from this 1% stock solution, we will take 1 centimeter cube out of it. 1 centimeter cube of 1% stock solution. 1% starch is here. So this will remain 9 centimeter cube over here. To this we will add 9 centimeter cube of water. So what will it happen? It will become the 10 centimeter cube of, this was 1%, now it will be 0.1% because we have reduced the concentration by 1/10. Then next is we take 1 centimeter cube from here, and the way I am doing it, you have to do it in the same way in the examination. So we write 1 centimeter cube of 0.1% S. So we are left with 9 centimeter cube of 0.1% S, which is available for use. And to this one we will add 9 centimeter cube of water. So this will become the 10 centimeter cube of, now the concentration will be 0.01%. So we will do it in the next step. Now we will take 1 centimeter cube from this 0.01%. So it will remain 9 centimeter cube of 0.0 for use. So we will take 1 centimeter cube of 0.01% S, and to this we will add 9 centimeter cube of water. So it will become, now the concentration will be 0.001%. So we can do it continuously, and I have. So first dilution is that we have been given a 1% copper sulfate solution. We call this as a stock solution. And there is W, which is the distilled water with us. And we have to reduce the concentration of this solution by the factor 10. That means when we have to do it by the factor 10, first of all, 1% will become 0.1 when we divide by 10. The second will be 0.01, because when we divide 0.1 by 10, it will be 0.01. And this will be 0.001. And the last one will be 0.2 0.0001. Means we are decreasing the concentration successively by a factor of 10. So what we will do is, this is a syringe which has the capacity of 1 centimeter cube. We'll use the 1 centimeter cube syringe and take out 1 centimeter cube from the stock solution and put it in the first beaker, where we have to reduce its concentration by 1 factor 10. Then we'll use another syringe, and this syringe will use to take out water, the 9 centimeter cube of water. So this is 9 centimeter cube of water, and we'll add it to this beaker. So we have taken 1 centimeter cube from the stock solution, 9 centimeter cube of water we have added to it. It becomes 10 centimeter cube of 0.01, because we have reduced the concentration by the factor 10. Now the next, we must actually wash off this syringe with the help of the washing solution. There's a beaker always in the examination that is marked with washing and erased. So after washing, we'll take now 1 centimeter cube from 0.1% stock solution. So this is 1 centimeter cube, and put it in the next beaker, which is 0.01 concentration that we have to make. And again, we'll take 9 centimeter cube of water and add to it. So we have made 10 centimeter cube of 0.01% concentration now, and this is only 9 centimeter cube left for the next use. That will be mentioned in the next part of the experiment, how to use it. So again, we'll take 1 centimeter cube from here after washing, put it in the next beaker, and add 9 centimeter cube of water from here. So we are reducing the concentration. This is the 9 centimeter of water, and we have made the 10 centimeter cube of 0.01% solution. So same will be, we will take 1 centimeter from this one, and we will add 9 centimeter cube of water. So in the serial dilution, we are using the stock solution only once, that is in the first dilution. Then the next dilutions are successfully done to these beakers. So the next part is how to reduce the concentration serially by 50%. Done one experiment here just to show it how we are doing the concentration reduction by the factor 110. Now the second type of the serial dilution is we have to reduce the concentration by 1/2. So in this case, what we do is we take the 50% of the stock solution and we add 50% of water to it. That is, the ratio is 1:1. For example, if we need to make 20 centimeter cube of the solution, we'll take 10 centimeter cube of solution and then we will add 10 centimeter of water to it. This will become 20 centimeter cube of the solution with the half the concentration. And with each concentration, we will do the same thing till we get the concentrations which are half of it. Like here, we have shown it here. If we take 10 centimeter cube of the 2 molar glucose solution, and to this we will add, it was 10 centimeter of the 2 molar glucose solution. We take 5 centimeter cube out of it, and we add 5 centimeter cube of water. So we get one more glucose solution. Then we take 5 centimeter cube out of this, and to this we add 5 centimeter cube of water. So this will be half of 1 mole. Now it will be 0.5 mole. Then we take 5 centimeter cube out of this and add 5 centimeter cube of water. So it will be half of 0.5, which is 0.25. Similarly, we are doing with the next one as well. So we are reducing the concentration here by the factor 1/2. I have taken the example here from the previous paper. This is winter 21 variant 31. So here we are provided with 1% protein solution P, and we have to reduce, we need to make, this is the 20 centimeter cube of it. So we need to reduce the concentration continuously by half. So what we will do is, we'll take, this is 20 centimeter cube, we'll take 10 centimeter cube out of it, 10 centimeter cube of 1% P, and to this we'll add the same amount of water, 10 centimeter cube of water. So this will become 20 centimeter cube of, now half of 1% is 0.5% protein solution. Out of this, we'll take 10 centimeter cube out. So we'll be left with 10 centimeter cube of 0.5% solution. So we have taken 10 centimeter cube of 0.5% P, and to this we add 10 centimeter cube of water. So it will become, the concentration now will be half of zero point 0.5, which is 0.25% of P. So continuously we will keep on doing this. Now we'll take 10 centimeter cube out of this. So this will be 10 centimeter cube of 0.25% solution. And we will be left with 10 centimeter cube here. And to this we will add the same amount of water, which is the 10 centimeter cube of W. So we'll now get the concentration half of 0.25, which is 0.125%. So we will do it continuously with the other one as well. So we'll be left with the 10 centimeter cube of 0.125. So I have the demonstration of this the dilution over here. Okay, now in this type of the serial dilution, we have been given a 10% stock solution and we have to reduce the concentration by 50% in each dilution. That means if we are starting with the 10%, the next dilution solution will be 5%. Half of 10% is 5. Next will be 2.5% because half of 5 is 2.5. This will be 2.5%, and then half of 2.5% is 1.25%. So this is 1.25%. And we have to make the 20 centimeter cube of each dilution, and we must have 10 centimeter cube of each dilution ready or left for use. So what we will do is, this is the stock solution, it's already 10%. Now we'll use a syringe and we'll take 10 centimeter cube out of this stock solution. So there was some air trapped in this. So I have taken 10 centimeter cube out of the stock solution and I put it in the next dilution beaker. And we will add the same amount of water to it. So we'll add 10 centimeter cube of water to it. This is 10 centimeter cube of water. So 10 centimeter cube of the stock solution, 10 centimeter cube of the water will reduce the concentration by 50%. So if this was 10%, now this is only 5%. Now we have to do the dilution successively. So in the next one, we'll take 10 centimeter cube out of this one. This is 10 centimeter cube of 5%. We'll add this to this one and we will add 10 centimeter cube of water to it. This to water. This is 10 centimeter of water. So now this concentration will be half of this one. So this was 5%, this is 2.5. So next we'll take the 10 centimeter cube out of this one and add it to this one, and then we will add 10 centimeter cube of water. So we will have 20 centimeter cube of 1.25% solution left for use. So remember one thing, that in each successive dilution we have to wash the syringe that we are using to take the solution with the help of the washing and the waste beakers mentioned. Now, moving to the proportional or direct dilution, we are asked about the two types of the questions in the proportional dilution. Either we have to make 10 centimeter cube of the solution, total solution with different concentrations, or we will have to make 20 centimeter cube of the solutions with the different concentrations. In this case, what we do is we use the formula C1V1 equals C2V2, where C1 we consider is the concentration of the stock solution. In the proportional dilution, we always use stock solution. So C1 is the concentration of the stock solution and we will dilute the stock solution only. V1 is the volume of the stock solution to be used and that we will calculate for the different concentrations. C2 is the new concentration that we will make and V2 is the final volume of the solution that they ask us to make. Either it can be 10 centimeter or 20 centimeter cube. Now, for example, I have taken the example here. We have a paper summer 20 variant 33 where we are asked to reduce the concentration from 20 to 12 by serial by this proportional dilution. So first of all, we have to decide about the dilutions. So we can make 18, we can make 16, and we can make 14 dilutions as well. So the 20 is already given there. In case of 20, what we do is we take the 10 centimeter cube of this and we add no water to it. So the concentration is 20%. Now we have to calculate it for 18%. As we said, C1 is the concentration of the stock solution which is given. V1 is the volume that we have to find is equal to C2 is the new concentration that we need is 18 into V2 is the final volume that we have to make, like 10 here. So V1 will be equal to 18 times 10 divided by 20. So 10 twos are 20 and 2 nines are 18. So for making the 18%, we need 9 centimeter cube of the stock solution, and to this we will add 1 centimeter cube of water. So as we make the further calculations, now instead of 18, it is 16. So 16 into 10 over 20, that means we'll need 8 centimeter cube of the stock solution and we will add 2 centimeter cube of water to it. Similarly, over here, we'll use 7 centimeter cube of the stock solution, add 3 centimeter cube of water to it. And finally, 12%, we need 6 centimeter of the stock solution and add 4 centimeter cube of water to it. In all of these, the total volume is 10 centimeter cube. 9 plus 1 is 10, 8 plus 2 is 10, 7 plus 3 is 10, 6 plus 4 is 10. We have been given the solution of the concentration 20%. So we have to make the different dilutions like 18%, 16%, 14%, and 12%. So in order to make 18%, and we of each dilution we need 10 centimeter cube. So we will use 9 centimeter cube from the stock solution, and to this I will add 1 centimeter cube of water. This is 1 centimeter cube of water. So this solution is 9 centimeter of the 20% solution and 1 centimeter of water. Its concentration is 16%. So in order to make the next one, this one is 18%. In order to make the 16%, we will take 8 centimeter cube as we have made the calculations. This is 8 centimeter cube from the stock solution. We put it in this beaker and we will add 2 centimeter cube of water in this case as the calculations are there. So this is 2 centimeter cube of water. Now this concentration will be 16%. Next is 14%. So, and for the 14%, we will use 7 centimeter cube of the stock solution. This is 7 centimeter cube of stock solution. And to this, we will add the 3 centimeter cube of water. So this is 3 centimeter cube of water. So this one is the 10 centimeter of 14% stock solution. Similarly, for the 12%, we will take the 6 centimeter cube of the stock solution and add 4 centimeter cube of water. That will be 10 centimeter cube of 12% solution. So there is another example where we have to make the 20 centimeter cube of the different concentrations. I have taken the example of the paper Winter 22 variant 31 over here. So the different concentrations that we can make, and if it is 2%, we can make 1.5%, we can make 1%, we can make 0.5%, and then 0%. So in order to make the stock solution is 2%. So if we take 20 centimeter cube of it and we don't add any water to it, it's 2%. Now in order to make 1.5% solution, so C1 is 2 into V1 we have to find equals C2 is now we need 1.5 times V2 we need total of 20, because we are taking this example where we have to make the total solution 20 centimeter cube. So this will be 2. So we will see that we need 15 centimeter cube of the stock solution, and to this we will add 5 centimeter cube of water, because 20 minus 15 is 5. Similarly, in order to, when we change this one, 1 into 20 divided by 2 means we need 10 centimeter cube of the stock solution, and we will add 10 centimeter cube of water to it. Similarly, for 0.5, it will be 0.5 times 20 divided by 2. That means 5 centimeter cube of the stock solution, and we will add 15 centimeter cube of water. And for the 0% consumption, we will not add any stock solution and we will just take 20 centimeter cube of water. 20 centimeter cube of each concentration, and they are starting with a 2% concentration. So we'll make the next concentrations 1.5%, 1%, 0.5 and 0%. So I have marked the beakers accordingly, what are the concentrations that we'll make. So this is 2%, which is the stock solution. So we'll make 1.5, 1%, 0.5, and 0%. So in order to make from 2%, we have to make it 1.5%. What we'll do is we'll take 15 centimeter cube of the stock solution. So this is, the syringe usually has a capacity of 10 per centimeter only. So this is 10 centimeter cube, and I will add 5 centimeter cube more grid from the stock solution. So this is 5 centimeter cube from the stock solution, and to this we'll add 5 centimeter cube of water. So this is 5 centimeter cube of water. So this solution has become 120 centimeter cube of 1.5%. We don't have to do anything with this. We have to do the dilution of the stock solution always in case of the proportional dilution. Now in order to make it 1%, we'll take 10 centimeter cube of this one, the stock solution. This is 10 centimeter cube of stock solution, and to this we will add 10 centimeter cube of water. So we have got the 20 centimeter cube of 1% solution. So next we have to make 20 centimeter of 0.5% solution. So for that we'll take 5 centimeter cube of the stock solution. This is 5 centimeter cube of stock solution in between 4 and 6. And to this we'll add 15 centimeter cube of water. So this will be 10, and then the next one will be 5 in order to make it 15. So this is 5 centimeter cube. So this is 20 centimeter cube of 0.5% solution. And the last one is where we have to make the 0% solution. That is, we will take directly 20 centimeter cube of the distilled water. We will not add any stock solution to it. So this is 20 centimeter cube. I put 10 before, this is the next one is 10 in it. So this is 20 centimeter cube of 0% solution. Thank you. I hope this video will be very helpful for your upcoming exams. You are now, you will be now able to do the dilutions of any type which will be asked in the examination.